This is a video on Chapter 8, Part 1 on ratio. Okay, a ratio is a comparison of two quantities that are measured in the same units. It is important that these two quantities have the same unit. So for example, for time, you can compare them as long as both of them are in seconds, or if both of them are in minutes, both of them are in hours. You cannot have a ratio where one part of the ratio is in seconds and the other is in, for example, minutes. They have to be the same. So a ratio has no units. That is why it is essential that before you compare the two quantities, they are already in the same units. Now the ratio of A and B can be written as A with a colon B, or we can also write it in a fraction form, A over B. The quantity that comes first will be written first. Alternatively, it will be written as the numerator of the fraction. Ratios can be written in a few different forms, and they are also equivalent. For example, 15 is to 3 is the same as 5 is to 1. They are equivalent. For example, 121 to 22 is equivalent to 11 is to 2, and so on and so forth. We can also have them in decimals. For example, 4.2 to 0.7 is the same as 6 is to 1. Now, when we want to have our final answer as a ratio, it has to be in the simplest form. In other words, they should both, on both sides of the colon sign, they should be integers. We should not have fractions, we should not have decimals. In addition, they should be written in the simplest form. So for example, 13 to 39 can be simplified by dividing both sides by 13 to arrive at 1 is to 3. These two are equivalent, but this is the simplest form. So carry on, try the rest of the questions, and I will just go through part D. So this is a case where these two quantities, although they are money, they have different units. So we have to change one of it to the same unit as the other. Now generally, I think students would prefer to change dollar, this $2 into cents. So 35 cents is to 200 cents. From here on, we simplify, we divide by 5 on both sides. We get 7 is to 40. Note that in the final answer, we have dropped the unit. We don't have to write cents anymore since they have the same units. Okay, so take note for parts E, F, and G, the units are different, but they are measuring the same type of quantity. Now the next question I will go through will be part H. Now notice that this is in a decimal, this is in a fraction, and this is in a decimal. So there are a few options you can do over here. First off, we can consider multiplying throughout by 10, because multiplying by 10 will remove this decimal, these two decimals over here. We will then result in 6 is to, now 2 and 1/4 is the same as 9 over 4. 9 over 4 multiplied by 10. Okay, and finally we have 15 over here. Continue with our simplification. We get 6 is to 9 over 2 times 5. So this will be 45. And here we have 15. Next step, we multiply throughout by 2 to get rid of this denominator over here. We will arrive at 12 is to 45 is to 15. And we see that this can further be simplified by dividing every single term by 3, resulting in a final answer of 4 is to 15 is to 5. And this is our final answer. So complete example 1 by yourself. Next, example number 2. So we have $248 divided among 3 girls in a ratio half, 1/5, and 1/3. You may be unfamiliar with ratios written down as fractions. We are more used to ratios written down, for example, as 2 to 1 to 3. But this ratio over here in a fraction is also equivalent. We can find its equivalent form with those with whole numbers, with integers. So we do so by finding part A, the LCM of 2, 5, and 3. Because I want to multiply all three numbers, all three fractions, by the same number to obtain an equivalent ratio with the simplest form. So let us write down the LCM of 2, 5, and 3 is 30. 2, 5, and 3, LCM is 30. So multiplying throughout by 30, half to 1/5 to 1/3 is equivalent to 15. Multiplying throughout by 30, and we get 6. Finally, 1/3 times 30 is 10. And this is the equivalent form for the ratio. So they did not ask for it, but this over here is our value for x, this is the value for y, and this is the value for z. Now part B, to find the amount of the largest share. By writing down in its equivalent ratio over here, we see that the largest share will be x. Okay, so it is the share for x is 15 units out of a total of 21 plus 10, which is 22 units. So the largest share, writing down in words, is 15 units out of 15 plus 6 plus 10 times of the original amount, 248. This will give us $120. Okay, next, example number 3. This is a case where we have two ratios, x to y, and the other ratio is x to z. And we need to combine all of them into one single ratio, x to y to z. To do so, we will want to rewrite x to y in a form that doesn't have the fraction. We also want to do so for x to z. So let's begin. X to y is 1 1/4 to 2/3. This is equivalent to 15:8. Okay, you just need to multiply it by the correct integer. I leave it to you to find out what that integer is. You can also use your calculator to help you. And the next ratio is x to z. At the moment, it is 1 3/7 to 5/6. Rewriting this to become 60 to 35. Of course, this is not the simplest form yet, but by writing it in this way, I know that these two x values should be the same. At the moment, in my first ratio, x has 15 units, y has 8 units. If I can rewrite this first ratio, x component, to become 60, then my y value will also multiply by 4 to give me 32. Now comparing my x values, now both of them are 60, which means that I can write my ratio of x to y to z as 60, the y value is 32, and the z value is 35. Okay? Please try example 4 by yourself. I will do example 5 with you right now. So in a chess club, the ratio of boys to girls is 7:4. It is good practice for you to do little indications like this. Boys to girls. 7 boys to 4 girls. So now they tell us that there are 56 boys. Find the number of girls in the club. Okay, so we can use statements like this. 7 units represents 56 boys. This 7 units over here. Now we need number of girls equals to 4 units. Okay, which is represented by 56/7 times 4, and we get 32. statements are important for us to understand what you are writing. Calculations and workings without explanations will result in no marks given. So making use of what we have done for example 5, carry on with example number 6. And now I will show you example number 7. So A to B is 3:4. Now we have B to C is 2:5. Okay. B to C has a ratio of 2:5. Find the ratio of A to B to C. Now here we see that B is what is common in both ratios. Okay, B appeared in both ratios. I would like this 2 over here to be rewritten to become 4. And I do so by multiplying the second ratio by 2 throughout. So we arrive at 4:10. Now in summary, A to B to C will now result in 3:4:10. Please try example number 8, example number 9. Okay, now I will go through example number 10. Given that 2x is equal to 3y, find the ratio of x to y. Answer is given over here, and students are usually very tempted to say that, oh, since 2x is equal to 3y, therefore x to y is 2 to 3. Unfortunately, this is wrong. In fact, the answer should be the other way around. And why is that so? We're going to make use of rewriting ratios in fractions to help us. So since I want x to y, it means that I want the ratio of x over y. If only I can rewrite my original equation to this form, x over y, then I will have my answer very clearly written for me. So from here, let's start. 2x is equal to 3y. I want x over y equals to something. Dividing by 2 on both sides, I arrive at x equals to 3 over 2y. Now I require x over y, so dividing by y, I arrive at x over y is 3 over 2. This is a form of writing the ratio, and therefore we read it this way. X to y is the same as 3:2. 3:2. And this is our ratio. So please try it for yourself for example number 11. Example number 12 is the same type of question. Since they want A is to B, rewrite the original equation as A over B and your answer will be clear. Next will be O-level types of questions on ratio. So whatever you have just covered is sufficient for you to attempt O-level questions. So I'll go through this question over here. This athlete spends 1.5 hours. We can rewrite it to become 1.5 hours or 60 plus 30, 90 minutes. I'm not sure which format is going to be useful for us for this question, but these are the options that we have. Now the ratio of time he spent changing, warming up, running. There are 3 components, 2 to 3 to 7. Calculate the time he spends warming up. So based on this, the question didn't say whether they want the answer in hours or in minutes. So it is really up to us. Let me stick to using hours because there's actually no reason to change to minutes. But we do know that sticking with hours will result in our answers most likely being hours. Okay, so time for warm-up. Is made up of 2 units out of a total of 2 plus 3 plus 7. 2 plus 3 plus 7. Out of a total of 12 units. 2 out of 12 of his time is spent on warming up. And the total amount of time he spent is 3 over 2 hours. Keep in mind that this is in hours. So my final answer will also be in hours. resulting in 1/4 of an hour. Oh, sorry, this is warming up. We should be looking at the middle value. So this will be 3/12 times 3/2, arriving at 3/8 of an hour spent warming up. Now in part 2, calculate the percentage of the 1.5 hours at the sports center he spends running. So the percentage of time spent of time running is actually 7 units out of a total of, again, the same denominator, 2 plus 3 plus 7. Now this time we multiply by 100%. We are not interested in the actual 1.5 hours anymore. So get an answer, round it off to 3 SF, which is, no, there's no need to round off to 3 SF. So we leave it as exact wherever possible. So this results in 58 1/3%. Okay, so now try this question. As well as example 13. This will be our homework for the weekend. This set of homework is due on Tuesday. All the other blanks in this set of notes, they are due on Monday. Okay, so in example 1, there are 5 more questions. Example 4 is your homework. 6 is your homework for the weekend. 8, 9, 11, 12, this O-level question over here, and example 13, due on Monday. The rest due on Tuesday. Now, change it to Wednesday.